Hello. All right. Hello, everybody. Welcome on back. Um, I know. Sorry for everybody about the spamming messages like, "Oh, I'm going live. I'm going live." I just figure after pretty much not doing any streaming or any coding for the most part yesterday, I want to make up for the weekend and do one. We're jumping right into it. All right. So yeah, we'll do some more clashing. This will probably be the last one for the day, but maybe we'll make it a little bit longer. But anyways, on the links. The links. Sorry. Okay. So, you must print true or false if you have enough paint to cover the whole inner surface of the house. The paint stock is Q in liters. There are N rooms in the house. We'll assume that 1 liter of paint will cover 5 square meters. In each room, walls, floor, and ceiling must be painted with 1 layer. Don't mind about doors and windows, paint them all. Okay, so let's see. The paint stock in liters. The number of rooms to be painted. So for in the range. So this is room's dimensions. So the walls, floor, and ceiling. Okay, so we're going to need a total. We'll do sum equals 0. Um, sum plus equals. Now, I want to say, you think about it like a die or dice. You've got the front, the back, the top, the bottom, the left, the right, the 6 sides. So you've got 6 sides of a room. It's talking, ceiling. So it's two of each of those. So it's, or no, I should take that back. Or yeah, I guess two of each of those. So anyways, x times x plus y times y plus z times z. Can I get away with uh, can I get away with being that lazy? And then I know that's not correct. We gotta deal with the liters and how much, like the square. Let's just see 58 and so 1058. All right. Um, so we've got 1 liter equals 5 square meters or meter. Okay. If 5 times q is greater than or equal to sum, print true, because that would mean that you had enough paint. Else, print false. And I think I'm doing that right. Let me go ahead and take these debug things out. Okay, so we got 1, 2, 3. Oh, all right. Fastest, boom. Third place. All right, that's not too bad. Let's see. Wow, 1 minute 29. That's good. We should take a look. Yep, times 2 for each of the. Because I think about that, like I've done a few challenges like that recently, where it's the front, back, left, right, top, bottom for surface area, but it was for cubes. It wasn't for like the inner uh, paint volumes. But anyways, cool. All right, let me. Also appreciate the couple of extra or more followers. I got another follower in between the streams, so getting really close to that affiliate. So that's exciting. Because I've been easily having over 3 average viewers at these things. So, well, not always, but better than the gaming streams. So I think I'll be pushing more with code streams, but I'll still put out some gaming streams here and there. Let's see. too distracted because these things like to pop off, but let's try to do. Oh man. Yeah, I'm close to horse racing and not even close on that. Yeah, let's open that one. Because this one, it's just a matter of finding out what the target is as far as should I go left or right. And, targeting the elevator first and then the exit at the end. Anyways, we're clashing, so. Okay. Print each prime. Uh, with the primes again. Okay, so. Uh, less than or equal. Okay. I've had a lot of these challenges recently. I should just get pretty good with, what's wrong with this? Is it because, okay. Um, Generating primes. So I think the whole general concept, I need to understand that, I suppose. Like a prime number is something that's only divisible by one in itself. And I think how I used to do it, because I had to calculate this back when I was getting my degree. It was actually one of the first challenges we ever came across because it's good in cybersecurity for the keys. But um, yeah, primes. So if it's divisible by, first you do like, 2. If it's even, any even number is not going to be prime. No, because it's divisible by 2. So, and then you got, being odd doesn't automatically constitute prime because it could be something else. Let's see. And then there's a few different ways to do it in Python. You can use the lambda function, which I'm not good with. Prime series. Yeah, I think that's the one that I've done before, or actually just most recently, is an iteration. I'm going to borrow some code here, or at least like the concept. I don't want to borrow the actual code. So it's doing, yeah, for n, we would do, ah, why do you got to do that? You're looking at a web page and then it's like, hey, you need to subscribe to this or click this or, anyways, all right. So, oh, it didn't give me any time on that. Anyways, the concept is for num in range 2 comma n. So it's like something like that. So I guess just because you're skipping 1 and 0. And then for num in range, say 100. Well, as an outer loop. Because this is just checking the divisibility, if that's a word. If num num out. So this would be like I and this would be j in the traditional like C++ and Java thinking. If num out, modulo num equals 0, valid equals false. If valid primes append num out. Not the best descriptive variables. Let's see. Valid equals false. True. should initialize it as true, and then if it's divisible by something, it invalidates it. Then, so what I need to do now equals true. So I need to switch it back after each num out. Then, yeah, because you don't want to divide it by 0 and you don't want to divide by 1. That's pointless. And now this one, the upper limit should be primes -1. So the last prime number appended to the primes is, I mean, I think that's just the best way to go about it to be accurate. I don't think that's optimal at all, but we're not going for optimization. We're just going for, well, now we need to do, so I just slapped 100 on there. So we're just testing 0 through 100, which is probably not nearly enough. I mean, the n input, that's how many primes, but that's not necessarily this number. In fact, this number is a lot different than that because this is a lot bigger than the actual primes are going to be, because a lot of those, like all the even ones, half of them are already going to be gone. So, like, well, let's test it. Let's just print the length of primes and see what we get. What is this? What, why? Index out of range. Oh. Primes, and then primes dot append 1. Or, well, can we, what are the, sorry, let me see. Prime numbers. Yeah, 1 to 100. 2, 3, 5. So they don't count 1, I don't think. So we would actually append 2. Yeah, let's see if that works. Okay, so now we have 28 primes, which means at best, and if we're looking for, wait, what? So we get an n, so for this example, 3, and we know that, sorry, so the primes, let me just go ahead and comment this out just for debugging purposes. We've got 2, 3, 5, 7. Those are the primes from 1 to 10. So if we got an n3, we would have 2 and 3, and then we're doing it that many times. So we actually need to format our, let's slap a return string on there. And then let's format that. And then at the end we'll just print return string. Get out of here. And then we're going to build that. Alright, so automatically, like, I would want to say, oh, come on. Oh, that's cool. I just found a, sorry, I'm looking at the prime numbers. Just because rather than calculating them, you know, like, I hope that we've got that correct. So now we need to, like, this model, all we need to do is, like, increase this, like, I don't know, a couple zeros. 10,000. It's going to be a lot. So let's see if it really is, and then how long is that going to take to calculate? It might time out. So that is, yeah. Let's scale that back to 0. Okay, so we have 171 primes. Let's print the last prime and see what we're getting. 997. Okay, so that's, oh geez, that is, Oh, wait a minute. Expected. Never mind. That was a dumb mistake. Sorry. It's 22333 because that's how we're formatting up to n. So n is just 3. So if we actually print out n, three, 5, 18, even the longest one, 46. Okay, so I mean the output's gonna be insane. Like, but we only need the first 46, and we actually have 171. So this is actually fine. We've got that. Now we just need to. Uh, yeah, actually, no. I've been getting more comfortable with doing these instead of while loops. For num, we can recycle that in range um, up to n. Yeah, now we're actually doing the. I want to say n plus 1 to make it inclusive. All right. Return string plus equals primes at num and string, and we can do that times num, and we want to start it's not going to work for the first one because num is 0. um, oh wait, we're multiplying it by primes. That just happens to be a convenient. Okay, sorry. So that value, and then let's do that. Jesus, so annoying. All right, there we go. Okay, so no. Hmm. Hmm. Let me see. So I want to see what we have for primes, just to see. Let's go ahead and take that back out. Whoa, whoa, whoa. We also have. Stop. See that? Okay, so there's an issue. We need to start 2, comma. There we go. Okay. Now we should be good. So let's take this back out because we had some numbers that were not prime in there. Okay, well, progress. But that plus 1, I did not need to add that. I don't know why. I've done that a lot. Okay. we're just getting an extra in the beginning, right? Uh-oh, extra in the beginning, and then that one was an extra at the end. So, oh, dang. 12 seconds. We're not even going to get it finished. We got it close. We got it close. So, not really. I mean, we just needed to chop those two off. All right. Well, we'll submit it. I mean, okay. Share the code. Why not? Yeah, 576 characters and definitely not. All right, let's do another one. Let's just ignore that one because that one is also that was like a two-parter. First we had to calculate primes, and then which I've done. I should know this by now. I've looked at that same little code snippet several times. Yeah, calculate primes in Python. So let's see. Oops. I think that's the one. Nice. Gotta love these pictures. Like, you know, Anchorman, Ron Burgundy. I don't know what that. Yeah. Well, I can't go all the way down. Okay. Oh, and the link. Sorry. Alright. You must output the string that consists of dash, underscore, and star. Convert the given string by replacing uppercase characters by. Okay, that's easy. So for char in S, we need a return string. Okay. If char is upper. Actually, first, let's see. Uppercase letters, lowercase, and all other characters. So first we need to do an outer if char dot is alpha. Wait a minute. Um, plus equals dash else is that it? Bada bing. Oh, third, that's not bad. Did I get third? So it looked like someone else just got it. Oh, maybe they were testing. Okay. So, yeah, not bad. Taiwan, Canada, nice. I love how it's like got people from all over. All right, cool. All right. While we're doing that, so yeah, with this one, let's see. Yeah, I've got the changing of the direction. I just need. Yeah, elevator position, I think, is what I'm not getting with this one. Because it's like up. Or wait. Or it changes in here. So it's almost like I need to save this tuple to something. Would that be a thing? Would I need to... And then I could access it to tell whether I need to go left or right. And also, wonder what the inputs are. Like, are they already saving this somewhere anyway? I mean, I guess I just need to figure out how am I determining where the elevator is, or if so the clone floor. Wait. Oh no, sorry, I had that backwards. The exit floor. So the clone floor is the current floor that the clone is on. So it's actually, let's go ahead and let's run one so you can kind of see it go through. Okay, so that's a single one. Well, even right here, like we need to say, okay, well the exit position. See, and that's why I'm checking to see if it's on the exit floor. Are we going on the? Oh, jeez, we've been going. All right. No. See, I don't get the all loud beeps there. Anyways, all right. Sorry. You have extracted a log file containing some comma separated value data. Your goal is to find the most frequent value on that given column. Wait a minute. All right. So hold on. The requested column. So let's see. The name of the column. You have to search action. Okay, so that tells you here. That's why. So we know that it's coming from this column. Is search, 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 search. What is 7? The length n of the table taking into account the header line. Um, hmm. Dang. Someone already got it. I'm still trying to figure out what I'm even trying to do. All right, let's see. Column. So I guess I'm trying to figure out. So we get the name of the column. So, and the first. The length of the table. So like here it's 7. The length of the table including the header line. So now I'm trying to figure out like how many. Well, I guess the line. So then we'd split. Okay. If I equals 0, line. Alright, so we're actually going to do a list, so, or column titles equals an empty list. We're going to do that split line, column titles equals line dot split, and then we're going to split on commas. Okay, so we're going to eat, and that only happens when I is 0, so the first iteration. So then we're splitting the column titles, and now after that, excuse me, column value, or well, actually, let's do a value dictionary. There you go. Else. Not very efficient, but I just want to skip that. So now, if it's not the header one, so now I guess we got to do sorry, I'm trying to think. Best way to go about this would be keeping track of the index. So first locating, let's see, let's make an index, set it to 0, and then so if we're in the header, we're going to do for item in alright, sorry. So I need to make sure I'm drinking enough water. Okay, so for item and column titles, this is how we'll keep track. If item equals, what is it? Column. Target index equals 0 as well. Oops. Okay. So a nice little loop just to find which index we're looking for with the columns. So now, and that'll only happen on the first iteration. So now we can go through every line after that, analyze line, and then actually, yeah. Actually, I'm going to name this row values. Values. There we go. So else row values equals line dot split commas. Okay, so now we'll have a list that we can pick which one with the target index. Okay, so if row values at target index in value dictionary, value dictionary of row values target index. If I had a little more time, I'd probably clean that up and make that a little better, but anyways, plus equals 1. Else value dictionary of row values target index equals 1. Right, so we're either incrementing it or we're assigning it to that. Now, we're going to find the most common one. So now for item in value dictionary, try to remember. We got 4.5 minutes. We gotta keep going. All right, let's see. Actually, we could do. Let's see. Do max equals negative 999. All right. Actually, we'll just do it in here if horribly inefficient, but sorry, I'm also trying to think. Let's see, max string equals that. All right, so now max equals that. Uh, there we go. So we can avoid doing this altogether. All right. Will that work? Okay. Nice. Fastest mode with 2 minutes to spare. Yes. All right. Yeah. I'll call it a win, though. I mean, I just don't like the times when I time out and I have no idea what I'm doing. Which happens. Okay. Nice. Hmm. Oh, good. It's almost getting close. I don't know. I think I might just keep this one at an hour or two. Getting. Let's do it. Nice. Oh, I need to exit out of these. Okay. Alright, another fastest. Given is a string with a sentence. You need to code a program that will count every unique character, how often it repeats in order, how they appear. Uppercase characters counts as lower. Spaces are no. Wow, that's very choppy, but alright, let's see. Okay, so it'd be like for char in string. We would make a dictionary, char dictionary. Let's see. If char not in char. Oh no, we can just do char in char dictionary. Char dictionary of char plus equals 1. Like just like we just did. Alright, else char dictionary of char equals 1. Okay, so then also char equals char dot lower. I don't know if that'll cause an issue for special characters or spaces or anything, but nice. Alright. So that should build our dictionary, except for, wait, let's see. Spaces are ignored. Alright, so um, let's just wrap it all in. If char not equal to space. That's one way we can ignore. I think that should work. Okay, so now we've gotten all these. I mean, as long as they don't have special characters. Right now, we got to do like for item in char dictionary print. It's the key. Let's see, the key plus value. So let me do a quick search here. All right. Let's see. What am I trying to do? Print keys of dictionary Python. There you go. Hmm. There are so many ways. Is it just item plus char dictionary of item? Would that be it? Then for, let's try it. No. What's wrong? Not int. Oh, okay, yeah. That makes sense. Will this work? Ah. Okay, so we just need to make a return string and build it with that. Okay. Alright, so string plus equals that, and then we can print out return string. Alright, I think that's good. Oh man. Oh, and plus We'll do that and then print return string, sliced that last one off. Better? No, what's going on? Doesn't, oh, oh, I see. There we go. Is that all of them? Maybe. Alright, fastest mode, 8 minutes. That's not too bad. Definitely a lot better from these ones, these people. Alright, share the code. Okay, how are we doing on time? Oh yeah, we can definitely do another one or two. Alright. Mexico. Poland. Oh, some Vinward. We also do, yeah, we can hover over Moscow, United Kingdom, Kumar. See, there's a lot of places that I've never even heard of. I would want to look up like Sendai. Ah, it's cool. It's like all these people are from all of them. Sorry, that's probably awkward. I'm stalking where all of you guys are from. All right. Don't wanna. And I know as soon as I go over here, it's gonna be like, oh, we're starting the clash. And I'll say, I don't really feel like working on that one right now. We gotta. Basically, it's just a matter of figuring out how they're keeping track of where the elevators are, and then going towards that. But oh, oh, and actually, is this the link? Have I been doing that wrong this whole time? Well, I did remember the first time this entire stream. Apologies. Alright, fastest mode. The Champernowne, wow, constant has the decimal value of that, where all natural numbers from 1 onwards show up in order. Given an integer n, find the nth decimal digit in the whatever that is constant. Okay, well. Okay. Champ equals empty string champ plus equals string of index started at 1. Okay. Index plus equals 1. So we're building our champignon, whatever that is, number. So we get that, and then, right, that should work. And now, print champ index of n. Isn't that about it? No. Index out of range. Okay, so 18 plus 100. Alright, minus 1. Alright, bada bing. There we go, we got it. 2 minutes. That's pretty good. Alright, let's do another one. How many have I... Let's see, 1, 2, 3, 4? Maybe 5? It's not bad. Anything over 4 is good. Because 4 is like the bare minimum. That didn't make sense. Anything over the bare minimum is good. Well, of course we're going to get 4 in an hour. Yeah, I've just really been procrastinating making that C++ video. Oh. Okay, so I guess those are actually like places in the country. That's Canada. It says Kitchener. Yeah, okay. It's like mine. I just specify the U.S., but like India. Yeah. So you know it's good. All right, here we go. Fastest. The goal is to print the closest power of 2, an integer. Um. Okay. Powers. Num in range. NB powers plus equals 2 to the num. So defined. Dang, they're already done. See, I told you, Xenoid's good. But, I want to say there's like an easier way. So we're looking for, we don't need to know what that is. We just need to know like the values of, then we need to find the closest one to that. Let's do diff equals 0. Um, okay, so I'm going to do target equals that. 2 to the num. So that kind of makes that one irrelevant, but let's see. If that one's greater than target, diff equals nb minus target, else diff equals target minus nb diff list dot append diff. And powers dot append target. Okay, so powers diff list equals an empty list. So as we go through, we're going to check them and then okay. Min equals 9999. 999. Uh, for item in diff list if item is less than min equals item, print powers at min. Wait a minute. I don't think I'm targeting the right thing. Okay, so try to explain a little bit what's going on here. I'm making two concurrent lists. One of the powers, so just the values, and then one of the differences of that value and the NB, which is really the target. Like we're actually trying to get close to. So like in the example, it's 20, and so 16 is one of the values in powers, and so that would be a diff of 4. That we're calculating that, and right here. Um, that's for a range of that. So we actually don't even need to go that crazy. Um, Now I'm trying to figure out. So I think I have an error here in this one without even running the test cases because min is just the got it. This is janky, but we're gonna do index equals 0. Min index equals index. There we go. I think that fixes it. Okay. So, and let's also do a min index. So finding the minimum difference is great, but we need to have an index, and then that index can correspond in the powers. So now we need min index because we kept them the same. Or that's why I said like concurrent. I don't know if that's the best way to describe that, but wrong. Okay, so 16, which we don't even need that anymore. Is that all? Is that all of them? Nice. Fastest mode. Yeah, 8 minutes. Well, let's do one more. Let's do one more. Share code. Oh, wait, 75? Wait, what happened? I thought I passed all the... Whoops. Huh. Oh well. Can't go back. Alright. Okay. Ugh. Oh, and yep, let's see. I think this is the link. Interesting that they have it there. Huh. Anyways, alright, so fastest mode. Find the best investment among the given cryptocurrencies. Okay. The most profitable crypto name. Alright, so N lines. What? Okay. How do you consider that more profitable than that? Like what are the do we have any more clues anywhere else? Good luck. All right. So, well, first off, we have to be able to vals equals that. Oh, oops. Vals equals crypto dot split, and we can just do it with the default space. All right, so now we would target. Hmm. Let's freak people out. Oh, it doesn't change depending. All right. Anyways, um, well, so that's how we'll target the name of the crypto. But now we need to figure out how they consider find the best investment among the given cryptocurrencies. So this one, it's increasing by zero point zero 0.02. This one, it's increasing by 100. All right, I'm gonna have to see some more examples. So let's print crypto. Let's go ahead and it's looking for Dogecoin. Okay, so I don't get it. Like, if this is what I'm thinking it is, it's a start and then it's a finish. Like, say this is a day of trading, and we're finding the best investment. Let's look at another one. Well, okay, so um, this is similar to the one that we just did. Uh, let's see, iota. I don't get it because this one's incrementing almost the same. Like the change from this number to this number is almost identical to this number to this number. So there's got to be some reasoning. And this one, you go from 300 to 0, so that seems like, an obvious not a good one. Oh, um, if titles, if len titles equals 0, print none, else print iota. Just for giggles. Alright, so I'm going to do titles as a list, and we're going to add, so after that, titles dot append vals. Okay. So that's where we get our titles from. But now we need to actually, I think all I did with that is just error handle for that case where there weren't any cryptos. So wait, let's see. So I just don't get it. Like XRP looks very similar. Like you're incrementing 0.02. Okay. 42 to 44. Whereas this one, you're incrementing by like 300, over 300. Why is BTC not, So then this goes down. I guess I just don't understand the stock market. And then IOTA. Oh, it's never mind. Sorry. IOTA is what I just printed. All right. You know what? Oh my gosh. Vowels. No, never mind. I had that wrong. No, they wanted. So I got BTC. Oh. Hmm. So my problem is I'm getting the very last one. I want to get the first one, so it's expected. Wait, so that's no, that's easy. That's always gonna pass now. So wait, now we're looking for BitConnect. So I'm printing them, and that's the and it want. See, that's what I'm trying to do is I'm trying to target the first one. IOTA is what they wanted, and then in this one, they want to be. Well, that's irrelevant because there's only the one. Well, so this one, do we pass it with? Yeah, okay. I was gonna say shouldn't matter because there's only the one. This one they're looking for the last one, and this one they're looking for the last one. What's this do for them? Oh, no, oh, titles. Yeah, see, that one's not. But that one will work because there's only the one, and that. So then why? Okay, so this one, this way of doing it is how. I don't know. We gotta figure out why they went with that one. Because obviously, I'm just pulling the first one. I'm not judging my decision based on the actual values. So, the values in this one, it increments by, what is that? 7 to 73. It's such a minuscule increment or increase. I mean, and then this one's a decrease. The one that we have, it increases by, a lot more, substantial more. Like we're up here. But, on the other ones, yeah, so I'm just not understanding why how they determine the best investment. So this is kind of like a hard coding cop out because we're just printing the first title. And like this one, you have no choice anyway. Oh wait, whoops. We're passing that one because oh yeah, yeah, I'll leave it off like this. So even though we're failing the test, there's only one. So as long as we're printing out 0 or -1, that would both pass that test. Um, there's only two, so you have a 50-50 chance of guessing this one right. But again, we're just going with the first one because that's what they want. And this one, this is an example of where it just doesn't make sense to me because this is like 100 increase change from this value to this value. Yeah, see, I want to look at Zenoid's code too, because I think they might be getting tripped up by the same thing. Like, it just doesn't make sense. And then they're just done with it. They're just like, nah. And I'm thinking, pretty tempted to say I'm done with it too. I mean, 'cause if we do that, we get everything except for the much money. And then this one we've just got because of this error handling. Like, if there aren't any, then just print none. Here we're just hard coding. Like, we don't care. We're just gonna print the cryptocurrency, the first one we hear about. Okay, so yeah. Now let's. Actually, I kind of want to keep going. I mean, not with this one. I'm good on this one. I don't want to struggle with that anymore. It just doesn't make sense. And I agree with Zenoid. Oh, 40%. What? Well, probably because I was hard coding it. Let's see. Actually, oh, dang it. I was going to say, let's look at. I have no idea. I'm clueless with Ruby. So the best prof. Is V divided by? Hmm. Okay. Well, I had no idea what that was looking for, so let's go for another one. Oh, and post the link in the chat. I think I'm doing that right. Alright. Okay. It's an interesting picture. Germany. Nice. Oh, look at that. It looks all cool. I don't know how I got this. I just put those languages up. I like that picture though. This is fun. Alright. Wow, I didn't realize how late it was getting too. Huh. I mean, out of this stream, we're just, like we're like one challenge over the usual. So, okie dokie. Reverse mode. Alright. So, I have no clue. Let's see. Wow. Alright, so the only thing I'm noticing is the output's 3 digits except with the exception of the first one, so that's not really a strong lead on how to figure this out. What? Get out of here. It was like 2 seconds. Nicely done, sir. Nicely done. Wow. That's a 10 digit. I was thinking maybe the first digit in the output is the. Should I ask the audience? Or, well, ask the fellow clashers? Hmm. Let's see. Hmm. Hmm. That is. I honestly have no clue. Let's see. 'Cause, I mean, my initial thought was, the number of digits had something to do with it, or, the sum of the values of each digit, individual digit. So that's usually what, these things have going on. This one's confusing. So 0, although that being the only two digit output, then here you're actually getting the same thing back. So that's strange. So what makes that unique to remain unchanged with this algorithm? And then, hmm, then you get something ridiculous. Although this looks like the first three digits of that number, so that's a little misleading. And then, but that's the only one where that happens. So I was looking for to see if this one was the first three digits, but definitely not. So then it's like, okay, so is the first digit something, the second digit? It's not the sum of all the digits. See, it's whatever you do to it to get the other one. Like this one, that's the weirdest input output. Yeah, I'll take I'll take a hint. I was about to start plugging them into a browser. And Raftak gave up. I don't blame you. I'm close to it. Let's see. 6. Oh, wait. ASCII? The first test case is the giveaway. Let me see that. I haven't pulled up an ASCII table in a while. Okay. So for 0, okay, 0 and 48. So char. Although interesting, but okay. So I have it backwards here. I'm actually getting. Then if you look at 159. Well, that makes sense that that's the only one I'm getting. I don't think this matters much, but no. Oh, I guess you do have to have it as a character. Alright, so. Hmm. Yeah, it's interesting though because I'm getting 0. So if I turned 0 into a character and took the ord of it. Oh, wait. Guess I'm not really understanding what. Because 159 is not even on the ASCII table. Let me look at another one here. Okay, so it's doing something. Same thing. This one we're actually printing out the input. No, it's already an int. Hmm. Let's see, we're getting again. So that's the input. Weird that we're. All right, so wait. Huh. Let's see. Trying to look for a relationship between 0 and 48. We've got 0. So that's the char of decimal. Is that a thing? Whoa. Okay, wait a minute. That's. Your input gets cast to an int while you want chars. Oh, let me just do it like there. Oh. Yeah, that's. Yeah, you want chars. Excuse me. Um, well, no, that's just getting the int of the. Let's see. Chars, though. Hmm. We're just really butchering it now. Um, yeah, that's not. That's nowhere close. That's okay. I'll take a peek once we time out, but I'll suffer it through. Thanks for the hints. I appreciate the attempt to help. It'll make sense once I take a look at it, or not. Either way. And then, let's see. Yeah, trying to look again at the ASCII table. Kind of like 31 and 100. What would even be 100 there? Yeah, it's alright. Oh, some map. Okay. Uh, Sorry, was it the sum of the ASCII of all the digits? I don't know. I got 14%. Oh, alright, on to the next one. Let's do another. Oh, that one was quick. Alright, fastest mode. Given an integer n, you have to return the difference d between the sum of the digits at even positions. First digit at position 0 and the sum of the digits at odd positions. Okay, so evens equals 0. Odds equals 0. Index equals 0. For char in string of n, if index modulo 2 equals 0, evens plus equals int of char, else odds equals. Okay, what are we doing? Given an integer, you have to return the difference between diff equals sum of digits at even, and so that's evens minus odds, I believe. Oh man, we got a bug. Okay. No. Oh, right, gotcha. Index. It's got to change. We get it, bada bing. Ah, Xenoid is very quick. Alright, well, let's do another one. Sum of ASCII, yes, yeah, so that's what I figured too. Like, I mean, in hindsight, that makes sense. I don't know why I didn't just try that. But I was trying to wrap my mind around 159 equaling 159. But alright, so given a string S that is formed only of digits, output the substring M of S whose value is the highest power of 2 among all substrings of S. If no substring M of S is a power of 2, output the digit 0. Okay, we'll just go ahead and output equals 0. Um, let's do powers of 2 again. Equals that. We just did something similar to this, and then we'll do a range, I don't know, for range, or for num in range 100. Powers dot append 2 to the num. And we want to start, I think we want to start at 1. Okay, so we get the first 100 powers of 2, right? Is that what we're, the highest power of 2 among all the substrings? Alright, so max equals -99. Then if hmm, actually let's just do that and then print max. Will that work? No, I did it for 1. 2. There. Okay. So looks like we just got one corner case holding this up. Maybe. Alright, so what's the deal with this one? Expected 1. Alright, so let's actually there we go. Alright, fastest again, Zenoid. He's or there, he or she, sorry. You're good, you're quick. Alright. Share the code. Let's go again. Alright. I feel like there's something else I could be doing while we're waiting for this. Let's see. Okay. Oh, sorry, I didn't share the link. You were given a patient. Every patient has a unique amount of teeth. Each tooth is either healthy, 1, rotten, 0, or pulled out, dash. Pull out any rotten teeth you find. Okay, so already I'm thinking I'm going to want a return string. And I'm going to want to print that return string. Now, yes, so if it's rotten 0, we got to change it to a dash. So, and here we'll do for char in row if char equals a 0 or return string plus equals dash. Else, I mean, this is pretty trusting of the, okay. Um, Maybe after every row, return string plus equals a new line? Does that make sense? End of line. Uh, okay. Do I need to chop off the last end line? Yes. Is that all of it? Alright, fastest. I did it. Nice. Alright. Let's do another one. Oh, I haven't been checking this chat. I have my console for the Twitch chat here. Okay. Oh, and let's toss that in there. Okay. Okay. Oh, what's up? Just carping them DMs. I did pretty good on my last couple. We'll see. Oh, so are you both from Germany? But then yours says Germany, like mine says United States. Like it's not specific. And then we got Squid from Rintil. Oh, I'm not even gonna try to pronounce that. I used to speak a little German, but I just butcher it like crazy. So, like very horribly. Oh, nice. I don't know how the rankings are. Let's see. So you got like 7, 14,000, then 8, 12,000. I guess that makes sense. I don't know. But level 20, jeez, that's insane. I got a ways to go before I get caught up to that. Hello. Alright, let's see if I get luckier on this one. Or if I just twiddle my thumbs for 15 minutes. Okay, fastest. In a chess club, people can bring chess pieces to sell. The cost of the pieces is the chess value of each one. 9 for the queen, 5 for the rook, 5 for the... Okay. Multiplied by $100 in the event that the set does not include a king, or $200 if it does. Oh. 5-piece set. Okay, so... So value equals 0. For char in S, if char equals p, let's see, value plus equals, how much for pawn 1? Elif, just going to take a guess, pawn, knight, plus equals 3, or char equals bishop. Ah, so I don't know what king is. Knight, king, let's put that. Actually, I should just, let's print S just to see what we're working with, because I don't even know. Value plus equals 1. Whatever, we'll leave it at that. Let's go ahead and do some test cases, see what we got. So P's, Q's, Q, R, B, N, P. So N, I'm guessing, is for knight, K for king. Okay, so we gotta change this to N, this to K. What relevancy is for king? 4. Elif, char. And you could also do this with the dictionary, too. But if we had more time. Oh, it says it right here. Anyways. So what am I missing? Just the Q? Oh, and that gets 9. Okay, so there's a couple more parameters. So multiplied by $100 in the event that the set does not include the king, or $200 if K in S value times equals 100, I think. Else value times equals 200, print value. See if that works. No. Oh, it's because we're printing the S. Get out of here. Okay. Not quite. Alright, so let me see. Capital P. So see, how are we not getting? So that's 1,000. Oh no, I think we got these backwards. There we go. Is that all of them? Nope. We got 2 of them. 3, but not. Okay, so Alright, well, we're on the right track. We just have some corner cases. So let's see what those. So this one, we're a little short. Let's see what the input is. QRB. I didn't do one for rook. 5 for rook. I think that might be what we're missing. R. Then value plus equals 5. That was it. Alright, cool. Alright. Good luck, Just Carpin. I'm going to move on to the next one. Actually, let's look at the other code. See, dictionary. That's much cleaner. That's what I was thinking about the whole time I was doing that. I was like, you know, and then P, like the multiplier. So it's either 200 or defaulted it. That's pretty clean. I like that. All right. Cool. Well, sorry. I will try to figure out how to take that chime off, or at least make it quieter. Oh, shoot. I was gonna say you just got it done. Nice. Good job. All right. Did I jump into? Sorry, I jumped out of our group and then into another one. Oh no, we're both in here. Cool. All right. So what are we doing? Shortest mode. Given a bit string consisting of bits from a random bit source with an unknown skew, the skew can be eliminated by inspecting all non-overlapping bit pairs from left to right and doing the following with each pair. 0, 0, discard, 0, 1, replace with 0, 1, 0, replace with 1. Okay. So we're going to be working on this bit string. First, I just want to see. So it looks like we're going to be combining. Let's see. Error. Oh. Okay. So right there, if len string modulo 2 equals 0, if it's even, right? Oh. Does not equal 2. Okay. Output error. And that makes sense. You need an even number of, wait, no. Print. Error. Okay. Because you need an even number to make this transformation. So for each one, I got it. So, now, non-overlapping bit pairs. Sorry, I was just looking through to see, do we deskew once or do we deskew until it's a single digit, or, because this way we're going to end up with a string, yeah, that's roughly half the size of the input. That's what I was doing. Oh, wow. Okay, so this is a little alarming. This is our input, and they're expecting us. So we do deskew more than one. So that's just an error. Oh, wait. Discard all the double zeros and double ones. Okay. Let's see. Let's do a dictionary. Oh, wait, no. For char in string. No, actually. No. Let's do for num in range. Lang string. There we go. So, and also -1. I think. Might have to change that. But anyways, so target equals string at num plus string at num plus 1. That's why I was doing the negative one there, or the subtract -1 there. Alright, so then target, and then if target equals equals. This is where I was going to do a dictionary, but that's whatever. I mean, we've only got 4 conditions, so 0, 0, or no, 0, 1, and we're going to do a return string equals empty. So that return string plus equals 0. Elif target equals the opposite, 1, 0. Return string gets a 1. Alright. That's it. I mean, that's all we care about. Then print return string. Now let's see if that chopped it up correctly, and we will. No. Oh, also. Wait, we got error. It's not looking good. We got zeros and ones all over the place, and none of them are lining up. All right, let me see if I. So, given a bit string, let me go back and let's refocus on it. So we're not doing it right. Okay. So one of these 4 conditions. Oh, jeez. Sorry, I was just curious. All right. All right. Well, let's see. I'm thinking I'm not getting the target correctly. Let me. Well, no, because what we're getting an output. We found this. We expected this. Let's print string again and see how they expected that. So from that to that, but they really wanted this. So do they do it twice? No, that wouldn't make any sense because oh, I think I got it now. Wait, what? No. I was thinking that good. If we were going from right to left, so that would be discarded. This would be a 0, discarded, 0, discarded, 1, discard. Yes, alright, so. Minus num. Uh, is this hacky or what? Alright, let's take it back out. Let's see. Hmm. Oh, wait a minute. No, that should be right. Unless I have those backwards. Hold on. Let's see. So that actually might be better. -1 minus num. So it'll be 0 at the very first one, and then it'll be 1. Okay, yeah, let's try that. Or is that gonna... Okay. Let's try that. So for this first one, and let's also do that. So we're getting 0, 0. And then 0, 1, 1. So this is not... So as num goes up... Oh. Oh. No, this is, -1. Okay, now... No, again, we're getting... Let's see. Let's print this again. 3 minutes. We might not get this, but let's go ahead and see. I want to see what we're getting for targets. Alright, so on this one, we're getting 0, 0, then we're getting 1, 0. Ah. -1, 0, comma. Oh no, that's not. Oh no, 2, 0, 0, 0, 1. Okay, okay. I think we're... Get out of here. I mean, it looks better. No. Nah. The result is empty. Output empty. I didn't even see any. I don't think I saw empty in here as a case. There we go. So there's nothing empty. I mean, we can at least pass that one. If len turn string equals 0, print empty, else print what it is. Alright. So we get that one. Then error. Oh. Printed equals false. printed equals true. And printed equals false. Elif printed equals false. There we go. So now we passed 2 just by yeah, I don't know. We were getting closer in like the lengths, but the ones and zeros are way off, so I don't know. Yeah, whatever we were calculating. Well, good job everyone else. Literally everyone else, except for, well, they quit, but what do we get for 2 past test cases? 28%. All right. Should we end on that one? Let's take a look at one more. And then I think that's probably good for the stream, because I do want to keep these videos somewhat realistically long for the YouTubes. But I don't know. There's people out there that might watch 3 hours of clashing. I don't think I would, at least not in one sitting, but alright. Let's see. Ah, sorry, blinked out. Alright, you must encrypt an urgent secret message. As usual, you configure the old encryption device with the daily key and type the message using its keyboard with only digits and uppercase letters. Usually you get a printed ribbon with the encrypted text formatted in fixed-sized blocks of characters, but this time nothing happens. The device is broken. You must send the message to your government within the next 15 minutes to save the situation. The only chance is to write a program. Oh, good God. Good Lord. The encryption key is a number. Its leftmost digit tells the length of each block. The next digits tell how to place the characters of each input block into the corresponding output block. The positions in the output blocks are numbered starting from 1. If the message does not fit into full blocks, the last block is padded with the start of the plain text. Hmm. Um, what is this website? Yeah, this is CodinGame. So go to here. Yeah, check it out. If you haven't seen CodinGame before, um, it's a really fun site. Huh. I think I should have stopped one shot. And I looked at algorithms. Ah, but just not when I'm doing it like 15 minutes. All right, let's focus. So let's take a look at the test. We have a numeric key. Its leftmost digit is n. So like that's our key, and then the plain text. Encrypted message formatted in space-separated blocks of n characters. Okay, so do ciphertext instead of return string, but basically the same concept as return string. Um, and then let's see. Encrypted message formatted in space. Oh, if you're new to programming, here, let me go ahead and uh, what's the best way to go about this? Um, hmm. Well, what I was gonna say is if you go to my YouTube, there we go. I'll get the link there. I actually do tutorials on Python and I have a website. There we go. See the website. My code has some tutorials linked here. I'm going to drop that. So there's like an explanation of Python, Java. Ah, thanks for the follow. But yeah. So there's my website. If you do the open source computer science, that's how you can kind of get. I mean, you can really do like YouTube's or watching these streams just to kind of watch coding. And don't worry, I'm not too serious about finishing this last challenge. Like it looks fun, but I'm not gonna stress if I don't get it. But anyways, yeah, because that's why I do a lot of my streamings is actually like teach programming. So yeah, check out that or the YouTube. Let me throw that in the chat as well. So that's actually where I have tried to upload all of my class that too. There you go. And I'm gonna take a leap and say I'm also translating that site into Arabic too and Spanish, hopefully German, maybe a few other languages. But right now, yeah, no problem. That's why I do it too. Like I had a lot of friends from other countries back in college, and I used to tutor some of them back when I was like an upper level student. So I enjoyed the teaching aspect of it and helping people. I just hope it's actually useful and not just a bunch of dribble to people. So, but yeah, like I said, I am translating that into Arabic. I have some friends that are proofreading it when I do get that finished. Same with Spanish. Um, then I'll just kind of add languages as I go. Depends on how long I do it. All right, so get to this thing. Um, so the size block is easy. What is the rest of it? The first of each block gets to the position 2, the second to position 1. Okay, so okay. So I'm thinking if you do like this, just so we can kind of see it, and then do their example, if we plop that down under it, and again, so these are the indices, I want to say, of the words, but we drop the comma and the exclamation point, so I'm not too sure, and it probably says in there if it's not a character. Let's see. Okay. So the input blocks. Okay. Anyways, I think I get it now. So since the input block is only 5 characters, it only takes the first 5 characters of that first thing, whatever it is. So we're gonna have to do words equals message dot split. I'm guessing. So then we have each individual word to be encrypted, and we're only encrypting the first characters, and it's all uppercase. So, and we're going to have, let's see, cipher word equals that, and you missed the 5. Oh yeah, so the 5 in this situation is actually that's just to determine the length of the block, so you actually don't want to include it in this. I did this so you can see that the indices line up. So this is indice 2, indice 1, indice, or index, I guess you could say, index 2, index 1, index 5. And if you look over here, index 2 Hmm. Actually, never mind. All of these need to be minus 1. So the reason I say that should be 1, 0, 4, 2, 3, I think. So if we're going to do that, because if you look at the E, that would be an indice 1, so 0, 1. So, but they want it to be the first letter. And then, so basically they're doing 2, 1. They're just taking the first letter and the second letter and they're flipping them. So EH and then OW. So there's that. And then 5, 3, 4. So they're doing the last letter, the third letter, and then the fourth letter. So wait a minute, that's not right either. Because yeah, there's something. Because L is actually the 1, 2, 3, fourth one. The fifth one is D. Huh. I thought that worked. I mean, so for the first two characters, that makes sense. We've got 2, 1. So, like, let's actually, let's print key. I want to see a couple of the keys that they have. So that, okay. All right, so see this one, it's 9 digits. So then we've got 3, 6, 9. And those are the numbers 1 through 9. So the first one, the second one, at least that's the way I'm kind of understanding it. Wow. Let's see. So, hmm. I'm also noticing that there's no punctuation. But that's what it looks like. So the first one, that's how many digits you're messing with, or your block size. And then the next so many digits in the key are the order of the characters in this plain text. But I think I'm just off by something. So let's go back and look at like if this is really hello encrypted to that. So let's do hello. So and even before that, let's do 1, 2, 3, 4, 5. So let's see if we match this. So if we did 2 is E, 1 is H, 5 is O. See right there, automatically it's not right. So, but that key, come on. Oh no, yeah. So 2, 1, 5, 3, 4. So 2, 1, 5, 3, 4. See, so I guess I'm just not understanding that correctly. Hmm. Because if that was EHL is either 4 or 3, could be this is 2, 1, 3, 4, or 3, 5, 4, or it's 2, 1, 4, 5, 3. because the 4 and the 3 are interchangeable because they're L's. Whereas this one, world would be 2 1 LD. Okay, let's do that. 1 2 3 4 5. Oops. 1 2 3 4 5. Okay. So L is 4, D is 5, and R is 3. Okay, so 21453. And we only got 30 seconds. We're not going to finish this one. But, and actually, I think I'm probably going to be done after this, at least for this stream. But, yeah, like, I want to say that the instructions are wrong, but, I mean, I'm sure it's more something. Yeah, so right there it says the ASCII characters may contain ones that'll be ignored. So like the comma and the exclamation point. Yeah, none of us got it. And I don't understand Ruby, so well, let's take a look at Carp and them DMs. That's what we called. Nice. Yep, that's where I was at too. But yeah, I don't know. That one was weird because it looked like it wasn't the correct key that they were wanting you to find. So, but anyways, yeah, I think that's definitely good. It's over double what I usually try to do for the streams, but yeah, I might pop on again, or I might actually keep clashing, but I don't know if I'll stream again tonight. I'll probably still clash again more tonight, but anyways, thanks for stopping by. Thanks for the follow, and yeah, like I said, check out all those resources. My Twitch profile has my code pen, which is where that open source computer science link is, and my YouTube. So I do gaming streams, but for the most part, I try to do like tutorial computer science coding stuff. So yeah, help yourself. Anything. If you have any suggestions, my Twitter's on there too, so you can always tweet some suggestions or whatnot. Or, you know, but I'm very sporadic with my streaming, so I tried to follow a schedule, but I'm not the best at it. So it might be hard to catch me live. So yeah, no problem. Well, I've already helped two of my buddies get into computer science, so through these websites and resources. So I mean, the more people I can help, awesome. So, all right, yeah. See you later, time traveler. Thanks for coming by, as always. Yeah, hope you guys enjoyed. So I'll see y'all later.